Hello everyone. This video is being made to help you run through Table 2 in CrystalMaker Assignment 3. And so we're in the feldspar section, and what we're curious about here is whether or not two different mineral phases will be in solid solution with each other. Now you should be familiar with the idea that if the percent or the relative difference between the radii of two cations in between two crystal phases is less than 15%, then they can usually substitute and be in what we call complete solid solution. So again, you should have talked about this in class already, but now we're just going to kind of quantify it and play around in CrystalMaker a little bit. So one thing we'll need for this section is the equation for percent difference. So the percent difference is equal to x2 minus x1, quantity divided by x1, everything there multiplied by 100, where x2 is the larger cation, or the cation with the larger radius, I should say. X1 is the cation with the smaller radius. Okay, simple enough. What cations are we talking about? Well, just like in the first table, you are given a link to a folder. That folder contains all the files that you should be looking at here. So you don't want to be looking at like albite high or a different albite file, because there are several in the crystal structures library. These are the ones we want you to look at. And we'll do this first row here. So we're going to be looking at the potassium in microcline versus the sodium in albite. And let's jump right into it. So I have CrystalMaker pulled up. I have microcline on the left. I have albite on the right. And I'm going to move my camera. CrystalMaker makes this very easy for us because the radius for the cations is listed in the sidebar right here. And in microcline, we're interested in the potassium. The potassium's radius is 1.43 angstroms. Simple enough. Okay, 1.43. How about albite? Sodium, 1.16 angstroms. Okay, 1.16 angstroms. Cool, we're moving here. Now we need to calculate the percent difference. So let's take another look. The percent difference is x2 minus x1. That's the larger minus the smaller, divided by the smaller, times 100. Okay? Again, you can do this on pencil and paper, just like in the first video. I said you could do this pencil and paper. I like to do Excel. So I have this spreadsheet set up. So x2, my larger cation, is 1.43 angstroms, and my smaller is 1.16. And that's the potassium, the sodium. Now we need to figure out the percent difference. So our percent difference equation, just to have that up at the same time, we want to do our math. So I will kind of walk through this a little slowly just so you can see what I'm doing. I type the equal sign. I open two sets of parentheses because we're going to need this group on top to be in its own set of parentheses. So x2 minus x1. I close one of the two parentheses. So now I have that top quantity. I divide by the smaller, x1. I close the second set of parentheses because we want to multiply this whole thing by 100 to get percent. And it spits out 23.27%. So we're going to round up and say 23.3%. So the percent difference, 23.3. And I have to ask myself, is 23 less than 15? It isn't. So these two, according to our math, are not going to be in solid solution with each other. So using that tutorial, you should be able to get through the rest of this table fairly easily, and then you'll have some questions below. Good luck.